Hello, in this lecture we will find out the radius of the biggest circle. In the drawing we have 4 circles. 3 circles are inside the biggest circle and the radius of this circle is equal to 4 units. The radius of this circle is equal to 9 units, and the radius of the smallest circle, this circle, is equal to 1 unit. And we want to find out the radius of the biggest circle. So, first of all, I will explain to you 2 new terms. The first term is internal length. Actually, 2 circles can be tangent to each other in 2 different ways, or I can also say that 2 circles can touch each other in 2 different ways. The first way is when 2 circles touch each other internally, or are tangent to each other internally. It is defined as internal length. Exactly, this is the internal length. These 2 circles are touching each other at point S. Point S is the point of tangency, and suppose that the center of the big circle is at point O, the center of the small circle is at point M. The distance between the centers of those 2 circles will be equal to MO, and in this case the distance MO between the centers of those 2 circles will be equal to the difference between the lengths of their radiuses. That is to say, the length of the radius of the big circle is capital R, the length of the radius of the small circle is small r, and the difference between the length of the radiuses is capital R minus small r. So MO equals to capital R minus small r. Okay? And you can see it from the drawing that SO is equal to the radius of the big circle, that is to say it equals to capital R, while MS equals to the radius of the small circle, that is to say it equals to small r. Therefore MO will be equal to SO minus SM. SO is capital R minus SM, SM is small r. So you can see from the drawing that MO equals to capital R minus small r. So in conclusion, you can say that when 2 circles are tangent to each other internally, or touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radiuses. In this case, it will be equal to capital R minus small r. So this is the first type. The internal length is the first type of tangency between 2 circles, and the second type of tangency between two circles is an external lunge. When two circles touching each other internally, when two circles touching each other externally, like in this drawing, those two circles touching each other at point S, or they are tangent to each other at point S. So they are touching each other internally, or they are tangent to each other. They are touching each other externally, or they are tangent to each other at point S externally. And here the distance MO between the centers of those two circles, you can see easily that MO will be equal to capital R plus small r. Again, the distance between the centers of two circles that have an external lunge between them is the sum of the lengths of their radiuses. In this case, the sum of the lengths of the radiuses of the circles is equal to capital R plus small r. Okay? So in conclusion, when two circles have an external lunge between them, then the distance between the centers of those two circles will be equal to the sum of the lengths of their radiuses. In this case is capital R plus small r. And when two circles are touching each other internally, then the distance between the centers of those two circles will be equal to the difference between the lengths of their radiuses. That is to say, here it will be equal to capital R minus small r. Okay, so those are the two types of tangency between two circles. This is the internal lunge, and this is the external lunge. Okay, in the internal lunge, MO, the distance between the centers, is equal to capital R minus small r, and in the case of external lunge, the distance MO between the centers of those two circles will be equal to capital R plus small r. Okay? So now let's start to solve the question. That is to say, we have to find out the radius of the biggest circle that those two small circles are located in. Okay, so we will define the center of this circle that is radius is 4 units as point A. We will define the center of this circle that is radius is 9 units as point B. We will define the center of this circle that is radius is equal to 1 unit as point C. And we have here this straight line is actually tangent to those three circles. So here, this point is the point of tangency of this straight line with this circle. That is to say, it is the point where the straight line touches this circle. So we define the point of tangency of the straight line of this circle as point D. And we have the second point of tangency of the straight line with this circle, this point is the point of tendency of the straight line with this circle. We define the point of tendency as point E, and we also have first point of tendency of the straight line with the smallest circle. This point is the point of tendency of the straight line with the smallest circle. So we define the point of tendency as point F. In the next step, we will join points A and D together by a straight line. Line segment AD is the radius of this circle. Why? Because line segment AD starts from the center of this circle, that is to say from point A, and ends at point D, that is a point on this circle itself. Therefore, it is the radius of this circle, that is to say it equals to 4 units. Likewise, we will join together points B and E by a straight line. Here, BE is the radius of this circle because of the fact that line segment BE starts from point B, that is the center of this circle, and ends at point E, that is a point on this circle itself. Therefore, BE is the radius of this circle, that is to say it equals to 9 units. So I'll write it here. And we will join points C and F together by a straight line. Here CF is the radius of the smallest circle. Why? Because it starts from point C, that is as the center of the smallest circle, and ends at point F, that is a point on this circle itself. Therefore CF is the radius of the smallest circle, that is to say it equals to 1 unit. Okay, so in the next step I will present to you a new rule, that is actually rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius. Drawn to its point of tangency. I read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So here the radius AD is drawn to the point of tangency. Here the radius AD, it is drawn to the point of tangency. That is to say, it is drawn to point D, that is the point of tangency of this tangent with the circle. Therefore, according to rule number 1, this tangent will be perpendicular to the radius AD. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Likewise, here the radius BE of this circle is drawn to the point of tangency. That is to say, it is drawn to point E, that is the point of tangency of this tangent with this circle. Therefore, the radius B in the tangent DE will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1, because whenever you have a radius that is drawn to the point of tangency, like here, then the tangent will be perpendicular to this radius, EB. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have here the radius CF. It is drawn to the point of tangency. That is to say, it is drawn to point F, that is the point of tangency of this tangent with the circle. Therefore, according to rule number 1, the tangent DF will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay. In the next step, we will define the center of the biggest circle as point O. We don't know what is the radius of the biggest circle. That is the thing that we are looking for. So we will define as capital R. Capital R will be defined as the radius of the biggest circle. So I write it here, that capital R will be defined as the radius of the biggest circle, the radius of this circle, that is the biggest circle, and we defined here, it is actually, this is the center of the biggest circle, therefore this point will be defined as point O. So we delete this point because the center of the biggest circle is at this point, that is point O. So in the next step, so here point O is the radius of the biggest circle. In the next step, we'll join points A and B together by a straight line. What is the length AB? A is the center of this circle, that is, its radius is equal to 4 units. B is the center of this circle, that its radius is equal to 9 units. And we have here external length between those two circles. And whenever we have an external length between two circles, then the distance between their centers, that is to say AB, will be equal to the sum of the lengths of their radiuses, that is to say it will be equal to 4 plus 9, and 4 plus 9 is equal to 13. So we found out that AB equals to 13 units, so I write it here. AB equals to 13 units. In the next step, we will draw perpendicular from point A to BE. So here, so this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point between the perpendicular from point A and BE as point P. This point will be defined as point B, that is the touching point of the perpendicular from point A and BE. In the next step, so before that, we have here quadrilateral ADEP. Quadrilateral ADEP has 3 right angles, 1, 2, 3, and the sum of 3 right angles is equal to 90 times 3 is 270. 270 degrees plus the fourth angle. So we focused on quadrilateral APDE. On quadrilateral APDE, we have three right angles. The sum of those three right angles, 1, 2, 3, is equal to 270 degrees plus the size of the fourth angle, that is actually angle ADP, plus angle ADP. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the sum of the angles in quadrilateral ADEP must be equal to 360 degrees. So, that is to say, the sum of the three angles, that is 270 degrees, plus the size of the fourth angle, in total they must be equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that angle ADP equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that this angle is a right angle, angle ADP, that is to say it equals to 90 degrees. So therefore, quadrilateral ADEP has four right angles, and therefore quadrilateral ADPE is a rectangle. Quadrilateral ADPE is a rectangle. So we know that quadrilateral ADPE is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to PE, AD equals to PE, but AD equals to 4 units. It is the radius of this circle. It equals to 4 units. So from this equation, 4 equals to AD equals to PE, we will derive that, we will conclude that PE also equals to 4 units. Here PE equals to 4 units. So we know that PE equals to 4 units, but BE is the radius of this circle that equals to 9 units. What is the value of BP? The value of BP is BP equals to BE minus PE. Again, BP equals to BE minus PE. I'll write it down. BP equals to BE minus PE. I'll repeat again. BP equals to BE minus PE. You can see it easily from the drawing. So BP equals to BE, that is 9 units, it is the radius of this circle, minus PE. We just right now found out that PE equals to 4 units. So it is, so BP equals to 9 minus 4. 9 minus 4 is 5. So BP equals to 5 units. You can write here that BP equals to 5 units. So we'll focus on the right triangle BPE. On the right triangle BPE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square, it is the square of the hypotenuse, must be equal to BP square plus AP square. I will repeat again. In the right triangle ABP, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BP square plus AP square. But we have already found out that AB equals to 13. Therefore, AB square equals to 13 square. 13 square is 169. And it will be equal to BP square. BP equals to 5. Here, BP equals to 5 units. So BP square is 5 square. 5 square is 25 plus AP square. So, in conclusion, we found out that 169 equals to 25 plus AP square. Here we will subtract 25 from this equation and we will get that 169 minus 25 is 144. So we get that 144 is equal to AP square. Here we will take a root out of this equation and we will get that AP equals to the square root of 144, and the square root of 144 is 12. So we found out that AP equals to 12 units. Here we can write down that AP equals to 12 units. But because of the fact that the opposite sides of a rectangle are equal to each other, so in rectangle ADPE, AEP equals to DE. In rectangle APDE, we know that AP equals to DE, AP equals to DE, but we just right now found out that AP equals to 12. So from this equation, 12 equals to AP equals to DE, we will conclude that DE also equals to 12 units. So we can write here that DE equals to 12 units. In the next step, we will draw perpendicular from point O to DE. Point O is the center of the biggest circle, so we'll do perpendicular from point O to DE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We'll define the touching point of the perpendicular from point O to DE and DE as point M. Again, the touching point of the perpendicular from point O and DE is defined as point M. This angle equals 90 degrees and this angle equals to 90 degrees. So here we will focus on quadrilateral, and here we will define this point as point S, and here we have quadrilateral ADMS. Quadrilateral ADMS has 3 right angles, and we know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the fourth angle, that is to say angle ASM, must be also equal to 90 degrees. And here OM is perpendicular, OM is the perpendicular from point O, therefore it is a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line OM at point S, then the sum of the angles must be equal to 180 degrees. That is to say, here I write it down. First of all, line segment OM is a straight line. Because of the fact that it is perpendicular, a perpendicular must be a straight line, and according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. If we focus on this side of the straight line OM at point S, then the sum of the angles must be equal to 180 degrees. So here we have 90 degrees plus the size of angle OSA so the sum of those two angles must be equal to 180 degrees. Here we'll subtract 90 degrees from this equation, and we'll get that angle OSA equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle OSA equals to 90 degrees. It is a right angle. So this angle is a right angle. It equals to 90 degrees. Therefore, triangle OSA is a right triangle, but we will focus on quadrilateral SPEM. On quadrilateral SPEM, we have three right angles, 1, 2, 3, and according to the rule that the sum of the angles in any quadrilateral must be equal to 360 degrees, then the fourth angle must be equal to 90 degrees. Angle MSP, that is the fourth angle, must be equal to 90 degrees in order to complete the sum of the angles in this quadrilateral SPME to 360 degrees. So we have 270 degrees. This is the sum of the four angles. Here 270 degrees plus the size of angle MSP. In total, they must be equal to 360 degrees in quadrilateral SPME. So here we'll subtract 270 degrees from this equation, and we'll get that angle MSP equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle MSP, this angle is equal to 90 degrees. It is a right angle. Therefore, quadrilateral SPEM that has four right angles is a rectangle. I write it down. Quadrilateral SPME is a rectangle because it has four right angles. So here we will define ME as X. So ME equals to X according to our definition. and according to the rule that the opposite sides of a rectangle are equal to each other, we get that ME equals to SP, ME equals to SP, but ME equals to X according to our definition. So from this equation, X equals to ME equals to SP, we will derive that SP also equals to X, SP also equals to X, and here we have ME equals to X and DE equals to 12. What is the value of DM? DM equals to DE minus ME. DE minus ME equals to DM, again DE minus ME equals to DM. I repeat again, DM equals to DE minus ME. So actually DM equals to DE, that is 12 units, D equals to 12 units, minus ME, and ME equals to X according to our definition. So in conclusion, we found out that DM equals to 12 minus X. Here, DM equals to 12 minus X. And we know that quadrilateral ASDM is a rectangle because it has 4 right angles, and the opposite sides of a rectangle are equal to each other. In rectangle, I'll write it down. In rectangle ASDM, in rectangle, this rectangle ASDM, the opposite sides are equal to each other, that is to say DM equals to AS. DM equals to AS. I'll repeat again. In rectangle ASDM, the opposite sides are equal to each other, that is to say DM equals to AS. But we found out that DM equals to 12 minus X. So we can write down that DM equals to 12 minus X. And from this equation, 12 minus X equals to DM equals to AS, we will derive that AS also equals to 12 minus X. AS equals to 12 minus X. So we can write here that AS equals to 12 minus X. We will define OM here. We know that in quadrilateral ADMS, the opposite sides are equal to each other, so AD also equals to SM. AD equals to SM, according to the rule that the opposite sides of a rectangle are equal to each other. But we know that AD equals to 4 units. AD equals to 4 units. From this equation, 4 equals to AD equals to SM, we will derive that SM also equals to 4 units. Here, SM equals to 4 units. So here we will join points A and O together by a straight line. Again, we will join points A and O by a straight line. What is the length of AO? What is the length of AO? A is the center of this circle, that is length is 4 units. O is A is the center of this circle, that is radius is 4 units. O is the radius of the biggest circle, that is radius is equal to capital R. This circle touch the biggest circle at this point, that is to say they have an internal lunge between them. And whenever you have an internal lunge between two circles, then the distance between the centers of the circles, that is to say AO, will be equal to the difference between the lengths of the radiuses. That is to say, in this case, it will be equal to capital R minus 4. Okay? It will be equal to capital R minus 4. So we found out that AO equals to capital R minus 4. We will define OM as Y. Again, OM is equal to Y according to our definition. OM equals to Y according to our definition. So, I'll write it here, that OM equals to Y according to our definition. And what is the value of line segment OS? The value of line segment OS equals to OM minus SM. Equals to OS equals to OM minus SM. So actually OS, again, OS equals to OM minus SM. So OS equals to OM equals to Y according to our definition, and SM, we have already found out that SM equals to 4. So in conclusion, we found out that OS equals to Y minus 4, OS equals to Y minus 4, in the next step we will focus on the right triangle, triangle AOS. We will focus on the right triangle, triangle AOS. So I will copy it in a new page. So we have the right triangle, triangle AOS. So this is the right triangle, triangle AOS. This is the right triangle, triangle AOS. And here we will implement the Pythagoras theorem in the right triangle, triangle AOS. So by PT, PT is the abbreviation for Pythagoras theorem, we will get that the square of the hypotenuse AO square equals to the sum of the squares of the perpendiculars equals to OS square plus AS square. So AO equals to R minus 4, so AO square equals to R minus 4 square, and it equals to OS square. OS equals to 4 minus x, so OS square is 4 minus x square plus AS square. AS equals to 12 minus x, so AS square will be equal to 12 minus x squared. So according to equation number 1, we found out that R minus 4 square equals to here 4. It is actually here we found out that OM, we actually, according to our definition, OM equals to Y. OM equals to Y, and SM equals to 4. OM equals to Y and SM equals to 4. So OS equals to OM minus SM. Okay? OS equals to OM minus SM. That is to say, OS equals to OM, that is Y, minus SM, that is 4. So OS equals to Y minus 4. OS equals to Y minus 4. So here, OS equals to Y minus 4. So, in conclusion, we found out that according to equation number 1, R minus 4 square equals to Y minus 4 square plus 12 minus X square. Here we will open the brackets on both sides of equation number 1 and we will get that according to equation number 1, R minus 4 square is R square plus 16 minus 8R, and it equals to Y minus 4 square. Y minus 4 square is equals to Y square plus 16 minus 8Y plus 12 minus X square. 12 minus X square equals to 12 square is 144 plus X square minus 24X. So here we have 16 in both sides of equation number 1, so 16 will get cancelled, and we add 8R, we will add 8R to this equation, equation number 1, and we will get that according to equation number 1, R square equals to Y square plus X square plus 8R. We added 8R to this equation minus 8Y plus 144 minus 24X. Here we will subtract X square and Y square from this equation, equation number 1, and we'll get that according to equation number 1, R square minus X square minus Y square equals to, here we will take 8 as a common factor out of those two expressions, and we get 8 inside the brackets. We will have R minus Y plus 144 minus 24X. So according to equation number 1, we found out that R square minus X square minus Y square equals to 8 times R minus Y plus 144 minus 24X. Okay? So in the next step, we will join points O and B together by a straight line. So, what is the value of OB? The value of OB, O is the center of the biggest circle, that its radius is capital R. B is the center of this circle, that is radius is 9, so OB, and we have an internal length between those two circles, so OB, the distance between their centers, will be equal to capital R minus 9. So here, from point O, we will draw perpendicular to BE. So I will draw it in a new page. We will draw perpendicular from point O to BE. Here OB, that equals to R minus 9. And from point O we will draw perpendicular to BE. So here I repeat again, from point O we will draw perpendicular to BE, so this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point of the perpendicular from point O and BE as point T. Here we have quadrilateral OTEM. In quadrilateral OTEM, we have 3 right angles. Therefore, the fourth angle must be equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So this angle must be also equal to 90 degrees. Therefore, quadrilateral OTME that has 4 right angles is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So here, so in quadrilateral, in rectangle OTME, the opposite sides are equal to each other. That is to say, ME equals to OT. ME equals to OT. But we know that ME equals to X ME equals to X. From this equation, X equals to ME equals to OT. We will derive that OT also equals to X. And OM is equal to Y according to our definition. OM equals to Y according to our definition. Again, the opposite sides of rectangle OT and E are equal to each other. That is to say, OM is equal to TE. OM equals to TE. OM equals to TE. But according to our definition, OM equals to Y. So from this equation, Y equals to OM equals to TE, we will derive that TE also equals to Y. TE equals to Y. And we know that BE is the radius of this circle, that is to say it equals to 9 units. BE equals to 9 units. Therefore, BT will be equals to BT equals to BE minus TE. You can see it easily from the drawing that BT equals to BE minus TE. I will write it down. BT equals to BE minus TE. That is to say, BT equals to BE, that is 9 units, minus TE, that is 9, minus TE, that is Y. That is to say, BT equals to 9 minus Y. Okay, so we will focus on the right triangle OBT. On the right triangle OBT, on the right triangle OBT, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OB, so the square of the hypotenuse is OB square. Must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to BT square plus OT square. So here OB is the hypotenuse that equals to R minus 9, so OB square is R minus 9 square, and it equals to BT square. BT is 9 minus Y, so BT square is 9 minus Y square, plus OT square. OT equals to X, so OT square is X square. So in conclusion, we found out that according to equation number 2, R minus 9 square equals to 9 minus Y square plus X square. So here we will open the brackets on both sides of equation number 2, and we will get that R minus 9 square is R square plus 81 minus 18 R, that equals to 9 minus y square. 9 minus y square is 81 plus y square minus 18y plus x squared. So here we have 81 on both sides of equation number 2, so 81 will get cancelled. We will add 18r to this equation, equation number 2, and we will get that r squared equals to 18r minus 18y here 9 minus y squared is 81 plus y squared. Okay, so r squared equals to 18r minus 18y plus x squared plus y squared. So here we will take 18 as a common factor out of those two expressions, and we will get that r squared equals to 18. So 18 is a common factor, so inside the brackets we will have r minus y plus x squared plus y squared. Here we'll subtract x squared and also y squared from this equation, equation number 2, and we'll get that according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y. Okay. In the next step, from point C, we will draw perpendicular to BE. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. We define the touching point between the perpendicular from point C and BE as point Q. Here we will focus on quadrilateral QSEF. Quadrilateral QSEF has 3 right angles, 1, 2, 3. Any quadrilateral that has 3 right angles, the fourth angle must be also equal to 90 degrees, so this angle will be also equal to 90 degrees. So quadrilateral QSEF has 4 right angles, therefore quadrilateral QSEF is a rectangle. So quadrilateral QSEF is a rectangle. In the next step, we will join points B and C together by a straight line. What is the value of BC? B is the center of this circle that its radius is 9 units. C is the center of the smallest circle that is radius is 1 unit. Those two circles have an external length between them. They touch each other at this point. Any two circles that have an external length between them, the distance between their centers will be equal to the sum of the lengths of their radiuses. That is to say, it will be equal to 9 units plus 1 unit. That is to say, BC equals to 10. BC equals to 10. I'll write it down. BC equals to 10. Here in rectangle QS EF, the opposite sides are equal to each other. That is to say, SF equals to QE. SF equals to QE. SF is equal to QE in rectangle QSEF. But SF equals to 1 unit because of here CF. Actually, it is CF equals to QE. Okay. In rectangle QCEF, CF is equal to QE according to the rule that the opposite sides of a rectangle are equal to each other. So CF is equal to QE. But CF equals to 1 unit because it is the radius of the smallest circle. From this equation, 1 equals to CF equals to QE, we will derive that QE also equals to 1 unit. QE equals to 1 unit. So we can write here that QE equals to 1 unit. BE equals to 9 units. So what is the value of BQ? BQ equals to BE minus QE. I'll repeat again. BQ equals to BE minus QE. I'll repeat again. BQ equals to BE minus QE. You can see it easily from the drawing. BE minus QE equals to BQ. So BQ equals to BE equals to 9 units. And QE equals to 1 unit, that is to say BQ equals to 9 minus 1 is 8. So we found out that BQ equals to 8 units, and we have already found out that BC equals to 10 units. So, in the right triangle, triangle BQC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is BC, so the square of the hypotenuse is BC square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BQ square plus QC squared. I'll repeat again. In the right triangle, triangle BQC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is BC, so the square of the hypotenuse is BC squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BQ squared plus QC squared. So BC equals to 10 units. BC squared is 10 squared, 10 squared is 100, and it equals to BQ squared. We just right now found out that BQ equals to 8, so BQ squared is 8 squared, 8 squared is 64, plus QC squared. QC is the missing variable, so we leave it as it is. So we found out that 100 equals to 64 plus QC squared. Here we'll subtract 64 from this equation, and we'll get that 100 minus 64 is 36. That is to say, QC squared equals to 36. We'll take a root out of this equation, and we'll get that QC equals to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6. So we can write here that QC equals to 6. And we know that QCEF is a rectangle. QC, we already found out that QCEF is a rectangle. And the opposite sides of a rectangle are equal to each other. That is to say, QC equals to EF. So QC equals to EF. But we just right now found out that QC equals to 6. So from this equation, 6 equals to QC equals to EF, we will derive that EF also equals to 6. So here EF equals to 6. So in the next step, we will join points O and C together by a straight line. But before that, from point C, we'll go perpendicular to OM. So this angle equals to 90 degrees, and this angle equals to 90 degrees also. We define the touching point between the perpendicular from point C to OM as U. We'll focus on quadrilateral UMFC. In quadrilateral UMFC, we have 1, 2, 3 right angles, and therefore the fourth angle must be also equal to 90 degrees. So this angle is also equal to 90 degrees. So quadrilateral UMFC is a rectangle quadrilateral UMFC is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, SF equals to UM, SF, it is CF. CF equals to UM. According to the rule that the opposite sides of a rectangle are equal to each other, we will derive that CF equals to UM, but CF equals to 1 unit because it is the radius of the smallest circle. So from this equation, 1 equals to CF equals to UM, we will derive that UM also equals to 1 unit. UM equals to 1 unit. So we can write here that UM equals to 1 unit. And what is the value of OU? The value of line segment OU? OU equals to here, OU equals to OM minus UM. Again, OM minus UM is equal to OU. That is to say, OU equals to OM. OM is equal to Y according to our definition. And UM, we just right now found out that UM equals to 1. So in conclusion, we found out that OU equals to Y minus 1. Here, quadrilateral UMEQ has 4 right angles. This angle is a right angle, this angle is a right angle, and this angle is a right angle. So here, if it has 3 right angles, then the 4th angle must be also equal to 90 degrees. So it has 4 right angles, therefore quadrilateral UMQE is a rectangle. I'll write it down. Quadrilateral UMQE is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AM equals to UQ, ME equals to UQ, ME equals to UQ, but ME equals to X according to our definition. ME equals to X. So from this equation, UQ equals to ME equals to X, we will derive that UQ also equals to X. So here, UQ equals to X. So what is the value of UC? The value of UC equals to X plus 6. UC equals to X plus 6, and OU equals to Y minus 1. In the next step, we will join points O and C together by a straight line. What is the value of OC? The value of OC we know that O is the center of the biggest circle and C is the center of the smallest circle. And if they have internal length between them, the biggest circle and the smallest circle have an internal length between them at this point. Therefore, the distance between their centers will be equal to the difference between the lengths of their radiuses. And the difference between the lengths of their radiuses is capital R minus 1. So OC equals to capital R minus 1. Okay? OC equals to capital R minus 1. So in the next step, we will focus on the right triangle, triangle OCU. This right triangle, so I will copy it in a new page. We will focus on this right triangle, OCU. On the right triangle, triangle OCU. Or OUC. So here, in the right triangle, triangle OUC, this triangle equals to 90 degrees, of course. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square will be equal to OU square plus UC square. I'll write it down. So in the right triangle, triangle OUC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OU square plus UC square. So OC square OC is equal to R minus 1, so OC square is R minus 1 square, and it equals to OU square. OU equals to Y minus 1, so OU square equals to Y minus 1 square plus UC square. UC equals to X plus 6, so UC square will be equal to X plus 6 square. So we got that according to equation number 3, R minus 1 square equals to Y minus 1 square plus X plus 6 square. We'll open the brackets on both sides of this equation, equation number 3, and we'll get that R minus 1 square is R square plus 1 minus 2R, that equals to Y minus 1 square is Y square plus 1 minus 2Y plus X plus 6 squared is x squared plus 36 plus 12x. So here we have 1 on both sides of equation number 3, so 1 will get cancelled. We will add 2r to this equation number 3, and we will get that r squared equals to 2r minus 2y plus x squared plus y squared plus 36 plus 12x. Here we will take 2 as a common factor out of those two expressions, and we will get that r squared, according to equation number 3, equals to 2 times r minus y plus 36 plus 12x plus x squared plus y squared. Here we subtract x squared and y squared from this equation number 3, and we will get that according to equation number 3, r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. Okay, this is equation number 3. So we will write down all the 3 equations together in one page, and we will solve those 3 equations in order to find out the radius of the biggest circle. So according to equation number 1, r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. So this is equation number 1. Equation number 2 is r squared minus x squared minus y squared equals to 18 times r minus y, and equation number 3 is r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. So here we will compare equation number 1 to equation number 2. In this way we will create equation number 4. Equation number 4 states that r minus x minus y according to equation number 1 must be equal to r minus x, r square minus x square minus y square according to equation number 2. So r square minus x square minus y square according to equation number 1 is 8 times r minus y plus 144 minus 24x, and it must be equal to r square minus x square minus y square according to equation number 2, that is actually equals to 18 times r minus y. Here we subtract 8 times r minus y from this equation, equation number 4, and we will get that 144 minus 24x equals to 8 times r minus y. Here we will divide this equation, equation number 4, by 10, and we will get that 144 minus 24x over 10 is equal to r minus y. So r minus y equals to 144 minus 24x over 10. Here we will divide both the numerator and the denominator by 2, and we get that according to equation number 4, r minus y equals to 144 over 2 is 72, minus 24x over 2 is minus 12x, over 10 over 2 is 5. So according to equation number 4, we found out that r minus y is equal to 72 minus 12x over 5. In the next step, we'll create equation number 5 that states that rx minus x square minus y square according to equation number 2 must be equal to r square minus x square minus y square according to equation number 3. So equation number 5 states that r square minus x square minus y square according to equation number 2 that equals to 18 times r minus y must be equal to r square minus x square minus y square according to equation number 3 that equals to 2 times r minus y plus 36 plus 12x. Okay. Here we will subtract 2 times r minus y from this equation, equation number 5, and we will get that according to equation number 5, 16 times r minus y equals to 36 plus 12x. Here we will divide this equation, equation number 5 by 16, and we will get that according to equation number 5, r minus y equals to 36 plus 12x over 16. Here we will divide both the numerator and the denominator of this side of equation number 5 by 4, and we will get that r minus y according to equation number 5 is equal to 36 over 4 is 9, 12x over 4 is 3x, and 16 over 4 is 4. So in conclusion, we found out that according to equation number 5, r minus y equals to 9 plus 3x over 4 So here we will create equation number 6 that states that r minus y according to equation number 5 must be equal to r minus y according to equation number 4. So equation number 6 states that r minus y according to equation number 5 that equals to 9 plus 3x over 4 must be equal to r minus y according to equation number 4 that equals to 72 minus 12x over 5. Okay, so here we will cross multiply this equation number 6, and we will get that 5 times 9 plus 3x equals to 4 times 72 minus 12x. We will open the brackets on both sides of equation number 6, and we will get that 5 times 9 is 45, 5 times 3x is 15x, and equals to 4 times 72 is 288, 4 times minus 12x is equal to minus 48x, so here we'll subtract 45 from this equation number 6, and we'll get that 288 here, 288 minus 45 is equal to 244, and we will add 48x to this equation number 6. 48x plus 15 is 63x. So we found out that according to equation number 6, 244 equals to 63x. Here we will divide this equation number 6 by 9, and we will get that 243 over 9 equals to 27, and 63 over 9 is 7. Here we will divide this equation by 7, and we get that x, on the equation number 6, x equals to 27 over 7, and according to equation number 5, we found out that r minus y equals to 9 plus 3x over 4. So here we'll substitute x by 27 over 7 because of the fact that x equals to 27 over 7, and we'll get that according to equation number 5, r minus y is equal to 9 plus 3, and x equals to 27 over 7 over 4. So r minus y equals to 3 times 27 is 81. Here we will multiply 9 by 7 and then we will divide it by 7 in order to have a common factor with this number, so it will be 9 times 7 is 63. So here 4 will move to the denominator, and we'll get that r minus y according to equation number 5 equals to 64 plus 81 is 144 over 7 times 4 is 28. So we found out. So here 144 over 27, we divide both the numerator and the denominator by 4. 144 over 4 is 36, and 28 over 4 is 7. So in conclusion, we found out that r minus y according to equation number 5 equals to 36 over 7, and x equals to 27 over 7. So we have equation number 2 that states that according to equation number 2, r squared minus x squared minus y squared is equal to 18 times r minus y. R squared minus y squared is equal to r plus y times r minus y according to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. So here it will be equal to 18 times r minus y plus x squared. Here we substitute r minus y by 36 over 7, and we will substitute x by 27 over 7, and we will get that according to equation number 2, r plus y times 36 over 7 equals to 18 times 36 over 7 plus x squared is 27 over 7 squared. So we actually found out that according to equation number 2, here we will actually multiply this equation by 7, and we'll get that according to equation number 2, r plus y times 36 is equal to 18 times 36 plus 27 times 27 over 7, Here we will divide this equation number 2, by 9, and we will get that according to equation number 2, 36 over 9 is 4, so 4 times r plus y is equal to 18 over 9 is 2, and 2 times 36 is 72, plus 27 over 9 is 3, and 3 times 27 is 81, so it is 3 times 27 over 7, three times 27 is 81, so we get that 4 times r plus y is equal to 72 plus 81 over 7. Here we will multiply 72 by 7, and then we divide it by 7 in order to have a common factor with 81 over 7, and we get that 4 times r plus y is equal to 7 times 72 plus 81 over 7. So 4 times r plus y according to equation number 2 equals to 7 times 72 is 504 plus 81 over 7. So we got that 4 times r plus y equals to 500 plus 81 is 585 over 7. Here we will divide this equation number 2 by 4, and we will get that according to equation number 2, r plus y equals to 585 over 4 times 7 is 28, but according to equation number 5, r minus y is equal to 36 over 7. So here we will add equation number 2 to equation number 5. So r plus r is 2r, y minus y is 0, so 2r equals to 585 over 28 plus, here we multiply both the numerator and the denominator by 4. 36 times 4 is 144 over 28, so we got that 2r equals to 585 plus 144 is 729 over 28. Here we will divide this equation by 2, and we will get that the radius of the biggest circle equals to 729 over 56 units, or in terms of numbers, it is actually equals to 13.018. Okay. So the radius of the biggest circle is equal to either 729/56 units, or you can present it in another way, that it equals to 13.018 units. So in the next step I will summarize the lecture. So here we have three circles that are inside the biggest circle, and we know that the radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, and the radius of the smallest circle is equal to 1 unit, and we want to find out the radius of the biggest circle. So first of all, I presented to you two new terms. When two circles touching each other, or they are tangent to each other, there is two types of tangency. The first type of tangency is the internal lunge, when they are touching each other internally, or they are tangent to each other internally. These two circles are tangent to each other at point S. Point S is the point of tangency. The center of this circle is at point M. The center of the big circle is at point O. The radius of the big circle is equal to capital R, and the radius of the small circle is equal to R. And the distance between their centers, that is to say OM, in this case it will be equal to the difference between the lengths of the radiuses, that is to say it will be equal to capital R minus small r. As you can see here, that OM indeed equals to OS, that is capital R, minus SM, that is small r. So MO equals to the difference between the lengths of the radiuses, that is to say capital R minus small r. And we also have another type of tangency between two circles. The second type of tangency between two circles can touch each other externally, like in this drawing. Point S is the point of tangency of those two circles. They are touching each other at point S, and in this case the distance between their centers, that is to say MO, will be equal to the sum of the lengths of their radiuses, that is to say it will be equal to capital R plus small r. So MO equals to R, capital R plus small r. And if we have an internal lunge between two circles, then the distance between their centers will be equal to the difference between the lengths of their radiuses. In this case, it is actually OM equals to capital R minus small r, and if two circles are touching each other externally, that is to say they have external length between them, then the distance between their centers will be equal to the sum of the lengths of their radiuses. In this case, it will be equal to capital R plus small r. Okay. In the next step, we defined the center of this circle as point A. We define the center of this circle as point B, and we define the center of the smallest circle as point C. The point of tendency between the straight line and this circle is defined as point D. The point of tendency of this circle with the straight line is defined as point E, and the point of tendency of the smallest circle with this straight line is defined as point F. We join together points A and D by straight line. Line segment AD is defined as the radius of this circle. Why? Because it starts from the center of the circle and ends at point D, that is the point on this circle itself. Therefore, AD is the radius of this circle, that is to say it equals to 4 units. For the same reason, BE is the radius of this circle, and the radius of this circle is equal to 9 units, so BE equals to 9 units. And here also CF, we join together points C and F by a straight line. So CF is the radius of the smallest circle, that is to say it equals to 1 unit. Then I present to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here, the radius OD, it is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of this tangent with the circle. Therefore this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees because of the fact that the tangent will be perpendicular to the radius that is drawn to the point of tangency. So this angle equals 90 degrees, and this angle also will be equal to 90 degrees. Likewise, here we have the radius BE is drawn to the point of tendency, that is to say it is drawn to point E, that is the point of tangency of the tangent with this circle. Therefore, the tangent will be perpendicular to this radius BE, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius, and here the radius CF is drawn to the point of tendency, that is to say it is drawn to point F, that is the point of tendency of this tangent with this circle. Therefore, the tangent will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Then we actually joined points A and B together. We joined together points A and O by straight line, and what is the value of AO? A is the center of the circle with the radius of 4 units. O is the center of the biggest circle that is radius equal to capital R according to our definition. So the biggest circle and this circle have an internal length between them at this point. Therefore, AO will be equal to the difference between the lengths of the reducers, that is to say it will be equal to R minus 4, capital R minus 4. And then, what is the value of OB? The value of OB, O is the center of this circle, of the biggest circle, and B is the center of this circle that is radius is 9 units, and the biggest circle and this circle have an internal notch between them at this point. Therefore, BO, the distance between their centers, will be equal to the difference between the lengths of their radiuses, that is to say it will be equal to capital R minus 9. And here we join points A and B together by a straight line. So what is the value of AB? A is the center of this circle that its radius is 4 units, and B is the center of this circle that its radius is 9 units. So, and those two circles have an external length between them and this point. Therefore, the distance between their centers AB will be equal to the sum of the lengths of their radiuses. That is to say, it will be equal to 4 plus 9, that is to say it will be equal to 13 units. So AB equals to 13 units. And here, from point A, we draw perpendicular to BE. That is to say, this angle equals 90 degrees and this angle also equal to 90 degrees. And we define the touching point between the perpendicular from point A to BE is point P. So here, quadrilateral APDE, we have here 3 right angles, 1, 2, 3, and the sum of 3 right angles is 90 times 3 is equal to 270 degrees, plus the size of the fourth angle, that is to say plus the size of this angle. In total, they must be equal to 360 degrees. So in quadrilateral APDE, the sum of the angles must be equal to 360 degrees, that is to say 270 degrees plus the size of angle ADP. In total, they must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we got that angle ADP equals to 90 degrees. So this angle ADP, actually it is angle PAD, because this is the missing angle, because this angle it is already equals to 90 degrees because we draw perpendicular from point A to P. So this angle equals to 90 degrees. This angle also equals to 90 degrees, and this angle also equals to 90 degrees. So this is the missing angle. So angle PAD equals to 90 degrees. Therefore, quadrilateral ADPE is a rectangle because it has 4 right angles. Quadrilateral ADPE is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to PE. AD equals to PE. But AD equals to 4 units. It is the radius of this circle. AD equals to 4 units. So from this equation, 4 equals to AD equals to PE, we will derive that PE also equals to 4 units. So we can write here that PE equals to 4 units. Then So PE equals to 4 units. BE is the radius of this circle that equals to 9 units. So BP will be equal to BE minus PE. Okay? From the drawing you can easily see that BP equals to BE minus PE. So that is to say BP equals to BE, that is 9 units, minus PE, that equals to 4 units. So 9 minus 4 is 5. So we found out that BP equals to 5 units. We have already found out that AB equals to 12 units. And the missing variable in the right triangle, triangle ABP, is AP. So we implemented the Pythagoras theorem in the right triangle, triangle ABP. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BP square plus AP square. AB square equals to BP square plus AP square. But AB equals to 13 units. AB equals to 13 units. So AB square is 13 square, 13 square is 169. We just right now found out that BP equals to 5 units, so BP square is 5 square, 5 square is 25. And AP square is the missing variable. So in conclusion, we found out that 169 equals to 25 plus AP square. We subtracted 25 from this equation and we got that 169 minus 25 is 144. So we found out that 144 equals to AP square. We took a root out of this equation and we got that AP equals to square root of 144. The square root of 144 is 12, so AP equals to 12. We found out that AP equals to 12 units, but because of the fact that we only found out that AP ED is a rectangle and the opposite sides of a rectangle are equal to each other, we conclude that AP equals to DE. AP equals to DE, but we just right now found out that AP equals to 12 units, so from this equation 12 equals to AP equals to DE, we conclude that DE also equals to 12 units, so here DE equals to 12 units. So here, from point O, we draw perpendicular to DE, therefore this angle equals to 90 degrees and this angle will also equal to 90 degrees. And here we have OM is perpendicular to DE, so it is absolutely a straight line. And here this angle is equal to 90 degrees. So 90 degrees at point S. Here at point S on the straight line OM, the sum of the angles must be equal to 180 degrees. So here we have 90 degrees plus the size of angle OSA. In total, they must be equal to 180 degrees. Again, 90 degrees plus angle OSA must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. We subtracted 90 degrees from this equation and we found out that angle ASO is equal to 90 degrees. So this angle is a right angle. Therefore, the green triangle AOS, is a right triangle. Okay? Then, in quadrilateral SPME, we have three right angles. 1, 2, 3. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. So here the sum of three right angles is 270 degrees plus angle MSP plus this angle. In total they must be equal to 360 degrees. So in quadrilateral SPME, the sum of the angles must be equal to 360 degrees, that is to say 270 degrees plus the size of angle MSP equals to 360 degrees. We subtracted 270 degrees from this equation and we found out that angle MSP is equal to 90 degrees. Here, angle MSP equals to 90 degrees. So therefore, actually quadrilateral SPME is a rectangle because of the fact that it has four right angles. So quadrilateral SPME is a rectangle, and we define ME as X, and because of the fact that quadrilateral SPME is a rectangle, therefore the opposite sides of a rectangle are equal to each other. That is to say, ME equals to SP. ME equals to SP. But ME equals to X according to our definitions. So from this equation, X equals to ME equals to SP, we will derive that that SP also equals to X. So here SP also equals to X. And so what is the value of dm? The value of dm, so here we know that de equals to 12 units, me equals to x, so dm must be equal to de minus me. dm equals to de minus me, but de equals to 12 units and me equals to x according to our definition, therefore dm will be equal to 12 minus x. Here dm or md equals to 12 minus x. So here we know that ASDN is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say DM equals to AS. DM equals to AS, but we just right now found out that DM equals to 12 minus X. So from this equation 12 minus X equals to DM equals to AS, we will derive that AS also equals to 12 minus X. So here AS equals to 12 minus X. And here we also know that AD must be equal to SM because of the fact that ASDM is a rectangle and the opposite sides of a rectangle are equal to each other. So AD equals to SM, but AD is the radius of this circle that equals to 4 units. So from this equation, 4 equals to AD equals to SM, we will derive that SM also equals to 4 units. Here SM equals to 4 units. Then we defined OM as Y. So here OM equals to Y according to our definition. Then we focus on the right triangle AOS. In this right triangle, what is the value of OS? OS equals to OM minus SM. Again, OS equals to OM minus SM. OS equals to OM minus SM. But OM equals to Y according to our definition, and SM equals to 4. So in conclusion, we found out that OS equals to Y minus 4. Here, OS equals to Y minus 4. And we already found out that AS equals to 12 minus X. And we have already found out that AO equals to R minus 4. So focus on this right triangle AOS. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AO square equals to OS square plus AS square. OS square equals to SO square plus AS square. So AO equals to R minus 4. So AO square is R minus 4 square. SO equals to Y minus 4. So SO square will be equal to Y minus 4 square. And AS equals to 12 minus X. So AS square equals to 12 minus X square. So here we open the brackets of this equation number 1, and we found out that R minus 4 square is equal to R square plus 16 minus 8R, and it equals to Y minus 4 square. Y minus 4 square equals to Y square plus 16 minus 8Y plus 12 minus X square. 12 minus X square equals to 144 plus X square minus 24X. Here we have 16 on both sides of equation number 1, so 16 will get cancelled. And also we added 8R to this equation, and we got that R square equals to Y square plus X square plus 8R minus 8Y plus 144 minus 24X. So here we took a common factor of 8 out of these two expressions, and we got that this expression equals to 8 times R minus Y. So, and we also subtracted X squared and Y squared from this equation number 1. So in conclusion, we found out that according to equation number 1, R squared minus X squared minus Y squared equals to 8 times R minus Y plus 144 minus 24X. Okay. Then we focused on the right triangle OBD. Actually, before that, from point O, we do perpendicular to DE. From point O, we do perpendicular to DE, so this angle equals to 90 degrees, this angle equals to 90 degrees. And we've already found out that, and we defined the touching point between the perpendicular from point O to BE as point T. So we know that rectangle OTME in rectangle OTME. OTME is a rectangle because it has 4 right angles. Here you can see OTME. So here this angle equals to 90 degrees. This angle also equals to 90 degrees, and here we drew perpendicular, so it has 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles in a quadrilateral OTME to 360 degrees. So the fourth angle is also equal to 90 degrees. Therefore, quadrilateral OTME has 4 right angles. Therefore, quadrilateral OTME is a rectangle. And the opposite sides of a rectangle are equal to each other. That is to say, ME equals to OT. ME equals to OT, but ME equals to X according to our definition. So from this equation, X equals to ME equals to OT, we will derive that OT also equals to X. And according to our definition, OM equals to Y, and again, OM in rectangle OMET, OM must be equal to TE according to the rule that the opposite sides of a rectangle are equal to each other. That is to say, OM equals to TE, but OM equals to Y according to our definition. So from this equation, Y equals to OM equals to TE, we will derive that TE also equals to Y. TE equals to Y, but BE is the radius of this circle, that is to say it equals to 9 units. So we know that BE equals to 9 units and TE equals to Y. So BT will be equal to BE minus TE. Okay, BT will be equal to BE minus TE. BE equals to 9, TE equals to Y. That is to say BT equals to 9 minus Y. And we have already found out that OB equals to R minus 9. So we focus on the right triangle OBT. We implemented the Pythagoras theorem on the right triangle OBT. According to the Pythagoras theorem, OB square will be equal to BT square plus OT square. OB equals to R minus 9, so OB square is R minus 9 square. BT equals to 9 minus Y, so BT square is 9 minus Y square, plus OT square. OT equals to X, so OT square is X square. Here we open the brackets on both sides of this equation, equation number 2, and we got that R minus 9 square equals to R square plus 81 minus 18R, that equals to 9 minus Y square is equal to 81 plus Y square minus 18Y plus X square. Here we have 81 on both sides of equation number 2, so 81 will get cancelled, and we also got here R square. So here we added 18R to this equation number 2, and we got that R square equals to 18R minus 18Y plus X square plus Y square. Here we took 18 as a common factor out of those two expressions, and we got that R square equals to 18R minus Y plus X square plus Y square. Here we subtracted X square and Y square from this equation number 2, and we found out that R square minus X square minus Y square equals to 18 times R minus Y. Then we know that quadrilateral QCEF is a rectangle. First of all, here from point C we draw perpendicular to BE. So that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So here we have 1, two three right angles in quadrilateral QCEF. Whenever we have three right angles in any quadrilateral, the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles in this quadrilateral to 360 degrees. So quadrilateral QECF has four right angles, therefore quadrilateral QECF is a rectangle. Okay, quadrilateral QCEF is a rectangle, and here we joined points B and C together by a straight line. What is the value of BC? B is the center of this circle that its radius is 9 units. C is the center of the smallest circle that its radius is 1 unit. Those two circles have an external length between them, therefore the distance between their centers is equal to the sum of the lengths of their radiuses, that is to say, it will be equal to 9 plus 1, that is to say, BC equals to 10 units. And what is the value of CF equals to 1? We know that we just right now proved that quadrilateral QCEF is a rectangle, therefore the opposite sides of this rectangle must be equal to each other, that is to say CF equals to QE. CF equals to QE, but CF equals to 1 unit because it is the radius of the smallest circle. So from this equation 1 equals to CF equals to QE, we will derive that QE also equals to 1 unit. So here QE equals to 1 unit. And we also know that BE is the radius of this circle, that is to say it equals to 9 units. So what is the value of BP? BP will be equal to BE minus QE. Again, BP will, it is actually BQ. BQ will be equal to BE minus QE. Again, BQ will be equal to BE minus QE. Okay, BQ will be equal to BE minus QE. So BQ will be equal to BE, that is 9 units, minus QE, that is 1 unit. That is to say BQ equals to 9 minus 1, that is 8. So we found out that BQ equals to 8 units. BC equals to 10 units, and the missing variable in the right triangle BQC is QS. So we can implement the Pythagoras theorem in the right triangle BQC. So in the right triangle BQC, again, we found out that BQ equals to 8 units, BC equals to 10 units. So in the right triangle BQC, according to the Pythagoras theorem, BC square must be equal to BQ square plus QC square. BC equals to 10, so BC square is 10 square. 10 square is 100 plus BQ. BQ equals BQ square. BQ equals to 8, so BQ square is 8 square. 8 square is 64. QC is the missing variable, so QC square equals to QC square. We leave it as it is. So here we got that 100 equals to 64 plus QC square. We subtracted 64 from this equation, and we got that QC square equals to 36. Then we took a root out of this equation, and we found out that QC equals to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6 units. But because of the fact that we have already proved that quadrilateral QECF is a rectangle and the opposite sides of a rectangle are equal to each other, that is to say QC must be equal to EF. QC must be equal to EF, but we just right now found out that QC equals to 6 units. So from this equation 6 equals to QC equals to EF, we will derive that EF also equals to 6 units. Okay. Then we focused on the right triangle on the quadrilateral UMFC. So here from point C we drew perpendicular to OM. So in quadrilateral UCMF we have 1, 2, 3 right angles. Therefore the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles in quadrilateral UCMF to 360 degrees. So quadrilateral UCMF has 4 right angles, therefore quadrilateral UCMF is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say CF equals to UM. CF equals to UM, but CF is the radius of the smallest circle that equals to 1 unit. So we can write here that CF equals to 1 unit. From this equation 1 equals to CF equals to UM, we derive that UM also equals to 1 unit. So here UM equals to 1 unit, and we have already found out that SU equals to 4 units. Here, what is the value of OU? OU equals to MO minus UM. OU equals to OM minus UM. Again, OU equals to OM minus UM. Okay, OU equals to OM minus UM. OM equals to Y according to our definition. We just now found out that UM equals to 1 unit. So in conclusion, we found out that OU equals to Y minus 1. OU equals to Y minus 1. And here you can see that easily that UC equals to X plus 6. And what is the value of OC? OC, O is the radius of the biggest circle, that is to say it equals to capital R. C is the radius of the smallest circle, that is to say it equals to 1. And the biggest circle and the smallest circle have an internal length between them at this point. Therefore, the distance between their centers, that is to say OC, will be equal to capital R minus 1. Okay, so here OC equals to capital R minus 1. UO, again UO, we just found out that UO here it equals to here UO equals to MO, that is Y minus UM, this is 1, so it is Y minus 1. UC equals to X plus 6, and OC equals to capital R minus 1. So we implemented the Pythagoras theorem on this right triangle OUC. According to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, that is to say OC square must be equal to OU square plus UC square. So here OC square equals to OU square plus UC square. OC equals to R minus 1, so OC square is R minus 1 square. OU equals to Y minus 1, so OU square is Y minus 1 square, plus UC square. UC equals to X plus 6, so UC square is X plus 6 square. We open the brackets on both sides of equation number 3. R minus 1 square equals to R square plus 1 minus 2R, that equals to Y minus 1 square. Y minus 1 square equals to Y square plus 1 minus 2Y, and X plus 6 square equals to X square plus 36 plus 12x. We have r in both sides of the equation number 3, so r will get cancelled. Then we added 2r to this equation number 3, and we got that r squared equals to 2r minus 2y plus x squared plus y squared plus 36 plus 12x. Here we took 2 as a common factor out of these two expressions, and we got that these two expressions equals to 2 times r minus y. So in conclusion, we found out that r squared equals to 2 times r minus y plus 36 plus 12x plus x squared plus y squared. We subtracted x squared and y squared from this equation, and we found out that according to equation number 3, r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. Okay? So we wrote down the 3 equations in one page. This is equation number 1, equation number 2, and equation number 3. And we created equation number 4 that states that r squared minus x squared minus y squared according to equation number 1 must be equal to r squared minus x squared minus y squared according to equation number 2. That is to say, 8 times r minus y plus 144 minus 24x must be equal to 18 times r minus y. We open the brackets here, and we got that. So here we subtracted 8 times r minus y from this equation number 4, and we got that 144 minus 24x equals to 18 times r minus y minus 8 times r minus y equals to 10 times r minus y. Here we divided this equation by 10, equation number 4, and we got that r minus y equals to 144 minus 24x over 10. Here we divided both the numerator and the denominator by 2, and we got that 144 over 2 is 72, minus 24x over 2 is minus 12x, and 10 over 2 is 5. So in conclusion, we found out that r minus y equals to 72 minus 12x over 5 according to equation number 4. So here r minus y according to equation number 4 equals to 72 minus 12x over 5. And then we created equation number 5 that states that 12 times. So here we actually have r minus y according to equation. We have equation number 5 that states that r minus y according to equation number r minus y according to equation number 2 must be equal to r minus y according to equation number 2. So here we have equation number 5 that says that rx minus x squared, r squared minus x squared minus y squared according to equation number 2 must be equal to r squared minus x squared minus y squared according to equation number 3. Okay? So here we subtracted 2 times r minus y from this equation number 5, and we got that 16 times r minus y equals to 36 plus 12x. Here we divided this equation number 5 by 16, and we got that r minus y equals to 36 plus 12x over 16. Here we divided both the numerator and the denominator by 4. 36 over 4 is 9, 12x over 4 is 3x, 16 over 4 is 4. So in conclusion, we got that r minus y, according to equation number 5, equals to 9 plus 3x over 4. Then we created equation number 6 that states that r minus y according to equation number 4 must be equal to r minus y according to equation number 5. Here we multiplied this equation number 6, and we got that 5 times 9 plus 3x equals to 4 times 72 minus 12x. 5 times 9 is 45, 5 times 3x is 15x, 4 times 72 is 288, 4 times minus 12x is minus 84x. So here we subtracted 45 from this equation number 6, and we got that 288 minus 45 is 243, and here we added 84x to this equation number 6. 48x plus 15x is 63x. So in conclusion, we got that according to equation number 6, 244 equals to 63x. We divided this equation by 9, and we got that 27 equals to 7x. We divided this equation by 7, and we got that x equals to 72 over 7. Then we have equation number 3 that states that r minus y equals to 9 plus 3x over 4. So here we put the value of x inside this equation number 5, and we found out that r minus y equals to 9 plus 3 times, and x equals to 27 over 7. So here we got that 3 times 27 is 81. Here we multiplied 9 by 7, and then we divided by 7 in order to have a common factor with this expression, and we got that r minus y equals to 63 plus 81 over 7 over 3. Here 4 moves to the denominator, and we got that r minus y 63 plus 81 is 144, divided by 4 times 7 is 28. So we found out that r minus y, we divided both the numerator and the denominator by 4. 144 over 4 is 36, and 28 over 4 is 7. So in conclusion, we found out that r minus y equals to 36 over 7, according to question number 5. And we already found out that x equals to 27 over 7. We have equation number 2 that states that r squared minus x squared minus y squared equals to 18 times r minus y. We substituted r squared minus y squared by r plus y times r minus y. So we got that r plus y times r minus y equals to 18 times r minus y plus x squared. So here we so we substituted r minus y by 36 over 7, and we got that r plus y, and here r minus y is 36 over 7, that equals to 18 times r minus y, and r minus y is 36 over 7, plus x squared. X equals to 27 over 7, so x squared is 27 over 7 squared. So according to equation number 2, r plus y plus 36 equals to 18 times 36, plus x squared is 27 times 7 over 7, because we divided the previous equation by 7. And here we divided this equation by 9, and we got that 4 times r plus y equals to